Today we're going to talk about how to find the area of a segment or circular segment of a circle. First off, a circular segment is the region bounded by an arc and its chord. If you look at the diagram we've got here, we've got circle O, and inside of that we've got a triangle with central angle theta. And you'll notice that one of the sides of the triangle forms a chord. Chord is just a segment that connects two parts of the circle. The circular segment is this region in that circle. So the next part of this worksheet goes through kind of the derivation of the formula that we're going to be using. First off, it says the area of the segment is equal to the area of the sector. If you remember from our last class, or a couple classes ago, that's basically this pi, minus the area of triangle ODE. So if you look at the next step here, we're going to replace the area of the sector with 1/2 times r squared times theta. That is one of the versions of the area of a sector formula we saw. And then replacing the area of the triangle is 1/2 times r, which is the radius here, times the sine of theta. You may recognize that as one of the area of triangles formula we saw where we had the two sides multiplied by the sine of the angle that's in between those two. Now if you simplify those and kind of put it together or clean it up a little bit, you get this equation, which is the area of the segment is equal to the radius squared over 2 multiplied by theta minus the sine of alpha. Now we haven't seen alpha yet, but this kind of explains what those are. R is radius. Theta is the measure of the angle in radians, so that means a pi symbol usually. And then alpha is the value of the interior angle in degrees. So what you'll notice with the two examples that we're going to do here is that you're going to have to do a little bit of conversion. You're going to be given an angle either in radians or degrees, and you'll have to convert to the other in order to set it up in this formula. And you'll see that with our first example here. So this says, find the area of the circular segment to the nearest tenth if a sector has theta equaling 150 degrees and a circle with radius of 11.5 inches. So that's the most straightforward part of it, is that our radius is 11.5 inches. Now, it says that theta is 150 degrees, but if you refer back to the formula, the measure of the angle in degrees is actually alpha. So I'm going to think of this as alpha is equal to 150 degrees. Now, in order to figure out what theta is, we need to convert that measure into radians. And if you remember from the last unit, what that is, it's going to take the 150 degrees and we're going to multiply that by our conversion factor of pi over 180 degrees. Now, when we did this in that prior unit, I had asked you to write this in the simplified version, which in this case would be 5 pi over 6. However, using it in this formula, you don't really even need to reduce it. You could have also used just 150 pi over 180. So you can actually go with either version and the formula should still work. All right, so once you have each of those three values, you take those and you plug them into the formula. So our area is going to be equal to our radius squared, so 11.5 squared over 2. And then in parentheses, we take our theta value, so I'll use 5 pi over 6, minus the sine of our angle in degrees. So it'll look something like that. Now, I'm going to recommend that you do this in a certain way that I think is the most efficient way to do this. So we're going to start by finding this first part out here. So I'm going to take 11.5, square it, and then divide by 2. And then I'm going to write that answer, so I get 66.125. And I'm going to write that outside of my parentheses. Now, this next part, the 5 pi over 6 minus the sine of 150, if I'm careful enough, and if your calculator allows it, you can actually type that in exactly as it appears. So we're going to go 5 pi divided by 6 minus the sine of 150. And you can close parentheses or not, shouldn't really matter that much. And you're going to get something that looks like this, so 2.1 and a whole bunch of other stuff. Now, you don't need to necessarily write all that on your paper, and I usually don't. I'll just write the first few and then I'll put a few dots to show that that continues. Then, keeping this value in my calculator, I'm then going to refer back to what I got on the first part here, and then I'm going to multiply those. So multiplied by 66.125, and that gives me a value of 140.05, which if I'm rounding to the nearest tenth, my area is going to be 140.1, and it's going to be square inches. Now, the other type of problem you're going to see is when your initial angle that you're given is going to be in radians. But again, just like we saw in the previous one, you're going to have to do a little bit of conversion. So it says, find the area of the circular segment to the nearest thousandths this time. So that's 2 decimal places. If a sector has theta, and in this case that actually is our theta, of pi over 8, with a radius of 7 centimeters. So the first thing we need to do is we need to figure out what alpha is. And that involves taking pi over 8, and this time multiplying by the conversion factor of 180 or 180 degrees over pi. As we had seen in the previous unit, those pi's are going to cancel. So we get 180 over 8, and for that one I'm just going to take 180 and divide by 8, and that gives me a alpha measure of 22.5 degrees. And once again, now that I've got those 3 values, I can take those and plug them into my formula. So my area is going to be equal to my radius squared, which in this case is 7 squared over 2. And then in parentheses, we've got pi over 8 minus the sine of my alpha, which is 22.5 degrees. As we talked about before, I'm going to square this and divide by 2 first. That I can do in my head. 7 squared is 49. So this becomes 49 over 2, or 24.5. And then, once again, I'm going to try to enter this next part into my calculator all as one step. So we've got pi divided by 8, and then minus the sine of 22.5. And the calculator knows correct order of operations, so it'll do that all correctly. And here we'll get 0.0100 and a whole bunch of other stuff, and you can maybe anticipate why I wanted you to round to the nearest thousandths. Keeping that number in my calculator, I'm then going to multiply that by the 24.5, and that gives me 0.245, and in this case it would be in centimeters squared. So that's finding the area of a circular segment. Hopefully that helps. As always, email or contact me somehow if you have any questions.